Hello everyone, welcome to my channel. In this tutorial, I wanted to address this GRE question where we have a circle with center O and we have a line segment DC. So there is a definition about this line in the question telling no line segment with endpoints on the circle with center O is longer than line segment DC. So which means we can translate this in a way that this is the diameter, because the diameter of the circle, it could be the like connecting two points in the circle, and it's a maximum. So which means no line segment that connects two points on the circle is definitely no longer than the diameter. So this is the diameter for sure. And then here we have another point on the circle called A, which is connected to the center O. And also we have AD segment. So, and the question is telling us that OA is equal AD and equal 3. So these two line segments are equal. And as for example, we know that AO is the radius, then DC also is a diameter, then half of that here also is radius, OD. So these two are equal. So this means that this triangle would be equilateral. So now we want to answer this question by comparing these two quantities. So quantity A telling us first computing the area of sector OABC, which is the shaded region here in this circle, and compare it with quantity B, which is the value 9. So then we need to find which one of these quantities either greater or equal, or we cannot say anything about these two quantities based on the given information. So I recommend you pause here for a moment and try to answer this question by yourself. I'll go over the answer in the next slide. All right, so here how we can answer this question. According to the question, we know that OA equal 3, and also is equal to AD, which is 3. And we know that OA is a radius. So which means that DC, which is a diameter, also should be 2 times of the radius. So we have 3 here and here for the diameter as well. So by looking at this triangle, as I mentioned before, we are dealing with the equilateral triangle. So this means that the angle that we have here is equal to 60 degree. And as the total degree here would be 180, by subtracting that from 60, we will get 120 for this one. So this is telling us that the sector ABC is twice as the size of the sector AD. So in order to find the area of the shaded region, we just need first to compute the area of the just like the total circle, and then divided by 2 in terms of getting the upper part, or the half of the area of the half of the circle. So, and multiply that by the 2 over 3, which is the fraction of the shaded region in terms of getting the area of the shaded region. So by substituting the value of R, which is 3 here, and cancel out the value of 2 in both in the numerator and the denominator, we will get something equal to 3 pi. So this is telling us that as a pi is a little larger than 3, so it's like a 3.14 something, definitely this multiplication is greater than 9. So backing to our question, which it was comparing these two quantities, we found that the area of the shaded region is greater than 9, which means quantity A should be definitely larger than quantity B. So thank you so much for your listening.